So we've done most of these basic graphs already. We've done linear equations. That was section 2.1, 2.2, and 2.3 were linear equations, those top three. Then we did 2 days of quadratics, parabolas, a couple different ways. And then we did a cubic, we did absolute value, and we did the cube root. So today we're going to finish 2.6 by doing the square root. And then we are going to do 2.7, which is the hyperbola. Remember the skateboard ramps ones, okay? So we're going to do the square root start. So if you saw a question, for example, with a square root in it, so you see a question with a square root, the first thing you do is you say, okay, it's a square root. I'm going to draw the basic graph so that when I draw my graph, it should look something like this. Now, I said this one was a little bit trickier because there's lots of options. So this is a half a parabola on its side. Now, if I put a minus in front, what do you think? Yeah, so let's number these quadrants. Which is quadrant 1? The positive, positive. This is quadrant 1 right here. Where's quadrant 2? Which way do I go? Right here. 3 and 4. Okay, 1, 2, 3, 4. So where do you think this one is? Quadrant 1, 2, 3, or 4? So it flips, just like think of a parabola as upside, upright, and then it flips. And that makes it flip down. So which quadrant? 4. And look at this, it's the other half of that parabola. Do you see it? If we put these together, it's a parabola on its side. And in fact, sometimes in math, you'll see something like this and be asked to graph that. And that just means both of these graphs together. So it looks like that. The other way, if we squared both sides of this, we get y squared equals x. That's the graph of y squared equals x. So sometimes you'll see that, okay? So that's one. Now, I can put a minus in different places, and different things happen with this particular graph. So what if I put the minus inside? Now, first of all, some people say you can't do that because there can't be a negative under the root. Right, the x could be a negative number. Like if we were doing a table of values for this, what kind of numbers can we plug in? So we could plug in 0. You get the square root. Negative 0, which is square root of 0 is 0. So that's okay. We can't plug in 1 because then you'd have negative 1, and that doesn't work. But you could plug in negative 1. Square root of a negative 1 is square root of 1, which is 1. What would be the next number we could plug in that would work nicely without having to estimate our value? Negative 4. So plug in negative 4. I can't remember how we got there. Fancy. So 2. Okay, let's just plot those points and see where this graph will be. Okay? And I did say this last class, if you're in doubt and you're not quite sure, but you know what the basic graph looks like, you can always do a table of values and see where it is. So you shouldn't get them wrong. 0, 0, negative 1, 1. Negative 4, 2. So where's it going? In quadrant 2. And remember, it doesn't look like a straight line, even though my points sort of look that way. It is a half a parabola on its side. Okay, so that way, a negative inside the bracket actually is a reflection on the y-axis.
Is there any way to get it into the third quadrant?
Yes. What do you think?
Negative y?
Nope. Like that. Right? So this is in the second quadrant, like that, with the negative under, and then a negative in front flips it. So this would be here. Be careful how you draw it. Think of it as sort of going towards the x-axis, right? It's going in, not away from. Okay, so there's sort of four options there, where the other graphs don't really do that, because if we took a parabola and put a minus inside the bracket, what's that equal to? It's just still x squared, because minus x squared is still x squared, so it didn't change. All right, so that sometimes, that is a reflection, really, I guess, if you think about it, but the reflection ends up looking the same. Yeah. Okay, so let's draw a few of these using our techniques and finding our intercepts and that center point. So what would be the center point, or the important point on a square root? Where to start that parabola? So this parabola doesn't have to start at 0, 0. It could start anywhere. And then you need to know which way it faces. Does it go up, down, right? So let's look at it. I think it's a little bit more confusing, this one. Okay, so let's start with this. Actually, let's add something else to it. Okay, so square root, so it has everything in it. Square root of x plus 1 plus 2. What's this plus 2 do to the graph? Moves it up 2. This moves it left or right. But just use that information to find your center. So what would our center be? What makes this 0? Negative 1. And this value, plus 2. Now, this is a regular square root, so the basic graph is our regular square root in that direction up there in the positive quadrant, okay? So that's what our graph is going to look like, but it's going to start at this point. So if we put the point on negative 1 and 2, there's my pipe cleaner. There we go. So I'm not going to draw it on here, but I'll show you what it would look like. So it's a half parabola, sort of like this, just like that, right? This is the basic graph in that direction. So it's like we picked this up and moved it so that it started at that point. But it's the same graph. So you have to picture that graph moving. So here it is in this direction. That's the right way for that basic graph, and it's going to go there. So which axis is it crossing through? The y-axis, so we need a y-intercept. Do we need an x-intercept? No, if we tried to find it, what should happen? What should we get as an answer? None, but this, yeah, I'll show you what happens. Okay, so y-intercept x equals 0. So y equals square root of 0 plus 1 plus 2. Square root of 1 plus 2, 3. 0, 3. So this is enough to draw the graph, because we know what the basic graph, it's going to go through this point here, and it's a parabola. Don't draw it as a straight line. That's our center. It starts there and you're done. So what happens if we try to find the x-intercept? So we know how to solve these. What do we do first? Move the 2 over. So this, at this point, you should say there's no solution. Why? A square root can't give you a negative answer. It always gives you a positive answer. But what if you kept going by accident? What would end up happening? What do you do to both sides? So this right now tells us no solution. Okay, that is it. You would stop. But sometimes I know we miss that and we keep going. So if you squared both sides, what then happens? We get 4 is equal to x plus 1. And x equals 3. So then you go over here and you say, okay, well, it has to go through here. But it doesn't. Okay? So just doing the algebra part is really not enough to draw a graph. You need to know the basic shape, where it's going, and what important points you need. If you look at the graph, it's supposed to go up this way and find the point. If you did a table of values, three gives us what point? If we plug 3 in here, what do we get? If we were doing a table of values and we plug 3 in, what do we get for the y value? Four. So there is a point on the graph with 3, but it's up here at 4. Right? It's not at 0. It's not an intercept. Okay? There is no point down here. Okay. Next example. So you want to find that center point, or that important point, the starting point. So what is it here? What makes the stuff under the root 0 is what? 4. And then what is added or subtracted from the end?
0.
0. So the center would be 4, 0. Okay, so if there's nothing added or subtracted to any of the graphs, that's what happens. That point would be 0. This is all, it is the center, but it's also which intercept? It's the X-intercept because y is 0, so that's also the X-intercept. So we already have an X-intercept. Now, is this the basic graph? Does it flip in any way? No. What you're looking for is not a minus under the root, but a minus in front of the X. Is that X negative? No. And in front, is it negative? No. So the basic graph for this one is still just the regular one. So this is still our shape, okay, and we're just going to pick it up and make it start at the point 4, 0. So 4, 0, and it goes like this. Do I need to find any more points? Nope, done. It doesn't go through an X or Y. I didn't put any more identifying points. You could add another point. How would we add another point? You wanted to. Table of values, just choose a value. What kind of numbers will work in here? What numbers could I plug in? What happens if I plug in 0? 0 minus 4. Negative under the root. And that's because there's no points down here. We actually can only plug in values that are, that's the domain, the values we can plug in. The values have to be bigger than or equal to 4. Right, here's 5, 6, 7. Any of these will work, but nothing before that will work because there's no graph there. Right, and we talked about this before, what values work in that. It's where x minus 4 is greater than 0. It has to be positive, greater than or equal to 0.
Do you state that on the
No. Nope. Nope. Not necessary. I don't ask for domain in anything. But it's useful to understand what it means is the values that work, right? So that is what works. So we couldn't plug this in. This is undefined. When it doesn't work, it's undefined. But we could plug in a 5, for example. What would we get? 1, because we'd have square root of 5 minus 4 is square root of 1 is 1. So there is a 0.51. Not necessary to put it on, because we're really looking for that basic graph starting in the right spot and going through the intercepts in the right place. That's what we're looking for. So if it doesn't cross any intercepts or any axis, then we don't need to show those intercepts, of course. Okay? All right, let's do another. So what we want to look for is the center and the basic graph. So what is the basic graph? Root x is like this, but this one is not root x. It goes down here. Now, if you see that minus sign and you say, okay, I can't remember which way it goes, how would you figure that out if you just really couldn't remember which way it flips? Or you weren't confident. Maybe you thought it flipped down, but you weren't confident. How would you do that? Again, table of values. Plug in some values that work and get a few points. If you get enough points, you're going to see where it goes. But you still need to know where the center is, where it starts. But by plotting a few points, you'll see which direction it goes in by those points. So that one comes down here, minus in front. What's the center? What makes the stuff under the radical sign 0? 0. And then 3. That minus sign doesn't affect where the center is. Okay? So our center is 0, 3, right here. And which way does our graph go? It comes down this way. Right? So if we were to pick that up and move it from that point, which axis is it crossing? The x-axis. This is already our y-intercept, so we wouldn't find another. These only have one or none. So we need our x-intercept. We're going to set y equals 0. And it should work out because it has one, and we can see that it has one by knowing what the basic graph looks like. Rearrange this. Let's bring the root x over to make it positive. Square both sides. And this is okay because it's a square root equals a positive number. So x equals 9. And that would be it. 9, 0. So x is 9, 0. Like I said yesterday, yesterday, when you draw your graphs, you could draw your basic shape on and then put your intercepts. That sometimes is easier, okay, than trying to get it to go through that exact spot you want. Okay, one more. And then you really just have to practice them. So there's a 3 in front. Be careful that it's not a small 3, meaning a cube root. Okay, that's a big 3 in front. What that does is changes the slope, right? Makes it steeper slope. That's it. So, but the points will take care of that. So, is this a regular basic graph or does it flip? Here's root x. What do we have in this one? There is a minus in front of the x that's under the root. Do you see it? Minus in front of the x that's under the root. So that is a flip. That's this one. Do you remember which way it goes? So instead of down, which would be in front, it goes this way. So that's our basic graph. It's a rotation or a reflection about the y-axis when the minus is under the radical sign. Okay, what's our center? Remember, it's what makes this 0. 4 minus x, what makes that 0? 4. 4 minus 4 is 0. And our y value? Negative 3. So let's look at what it would look like. 4, negative 3. And which way is it going? Let's use our pipe cleaner so I don't draw it. So here's the graph, this way. So there's our starting point. It's going to go in that direction. So which axis is it going to cross? Both, right? It's going to come up and cross both. So we need our X-intercept where y equals 0. Move the 3 over. You could square both sides at this point, or what could we do instead? Divide by 3 to sort of isolate that root, and that works nice in this case. So 1 equals root 4 minus x. Now square both sides. 1 squared. Let's move the x over. So I get 3. Is that following the direction I want it to go? Remember, this is my start, where I want it to start. It's following, so it's going to cross the y up here somewhere. So our y-intercept, let x equal 0. That's always our easier one. Four minus 0. Square root of 4. So I'm going to draw it first. Okay, so here's my start. There it is. And then put this point on. Okay, where do people go wrong with these ones? They forget that they're starting at this point and they extend the line in both directions by accident. Okay, so try to remember, I actually wrote start on here. So I'd remember that's where I'm starting, not at one of these other points. Okay, so the important part for any of these graphs is get your starting point. Remember where your starting point is on the basic graph and what the shape looks like. And then find your intercepts if you need to. If you know it's going to cross through, then you would find them. If in doubt, check your answer with the table of values. Plug a couple values in and see if your graph looks like it's the right way. Okay, I'm not looking for a whole bunch of points on your graph, but I am looking for the intercepts and your starting point. Those always have to be written on, and the test will say that, okay?